All right, hey everyone, Riley here from becominganelectrician.com. In this video, we will be looking at parallel circuits. So in our last video, we looked at series circuits, and the biggest thing to know about parallel circuits is, first of all, voltage is always the same across all of our branches, okay? And in the real world, we as electricians, we're essentially always using parallel. The reason we are doing that is because we want our voltage to be the same at all of our plugs and all of our lights. Now, there's a couple other things which we will quickly talk about regarding voltage, some basic principles, just like in series, how current is always the same. You can add up your resistance, you can add up your voltages, all your voltage drops. In parallel, things are a little different, and we will talk about those in just a second. But what I want to talk about first is I want to talk about series versus parallel in the wiring, okay, when you actually see it out there. So we are always wiring things in parallel, and again, that gives us the same voltage to our lights. So this is going to be our black wire, okay, so we'll say black. And then what we will do is we will just draw this, let's say this is our octagon. Okay, so what we're going to do is we're going to bring it into the octagon, and then we're going to splice on. Okay, so we're going to splice on to this light, let's say. So this is a little light. And then what happens is then we would have a white wire. Okay, so right here. And then so now this leaves the box and our wire would continue. And then we're going to do another octagon, because this is what's called series, and we do not wire like this in the real world because we get voltage drop, which I'll share with you in just a second, okay? So again, we have a white wire, and then what we would do is, let's say we have one of those little pigtail light bulbs, if you've ever seen those before. We are then going to splice on this right here. And again, this wire here is the white wire, this one's the black. They're a little hard to see. And then this would be going back to, let's say, the panel. Okay, so how this would work is if we had 120 volts, and if a voltage drop happens here, we might have 60 volts at the light and 60 volts at the light, depending on the resistance of each light bulb. So if they were both the same resistance, they'd get the same voltage drop. But as you can see, in order for this light to shine as bright as possible, we want it to have 120 volts. So let's give the same example here. Okay, so we have our black wire right here. And this is going to be our parallel. So this right here was series, and then this one here will be parallel. Okay, so same thing. Let's just draw our octagon that would be up in the ceiling, let's say, for our light bulb. And so what's happening here is we just splice on. So for example, you're going to see that this would still go to the light bulb. But what is happening is that we're just taking the wire from here. So we actually splice in the other wire, which would continue on, and I will now draw this light right here. Okay, so now this right here is going to be our white wire, just so that you can really see the difference. The gray and the white is a little hard to see. All right, so we're going to bring it into the box. You do your little jump over, okay? And then right here, we make a splice, and then one wire is going to be going to this light now. And then we also bring out another wire, and it comes up here to the light. Okay, so as you can see, what we're doing is we're splicing on. So again, if this was 120 volts right here, so 120 volts, that means that 120 volts is happening right here. And we splice on before it hits any resistive load. So we are keeping 120 volts going this way, okay? And since it's AC, so AC is just like this, so it goes back and forth. So we have AC, 120 volts going on both lines, okay? So 120 volts would be going to both ways, and let's just finish this off. So again, it's going to come here to the light, and in this case, if this is what's called like a dead end, so the very end of the circuit, we would then just splice it on directly to the light, all right? And then I'll get the yellow, and we will just finish this off. So again, you just kind of jump over, and it comes to here. So now this light has 120 volts, and this light has 120 volts. And inside of the actual octagon box is where we are making the splice to do our 120 volts. Okay, so sometimes it's a little confusing out there because when you look at the circuits, which we are now going to cover, it isn't as clear as that, okay? So for example, this is like what a circuit would look like when we are drawing the diagram. So for example, it'd be like this. You have like a resistor, and it comes back to here. And so you'd have like your source, okay? And then you're going to come here and you have like another resistor. And so it's kind of confusing because right here, let's just get a different color for that. So if we look at our other diagram. So you can see like where I made like my splice, right? This would be a splice and this would be a splice. So watch, I'm going to remove this one and bring this one back. So where I have these red dots, if you want to pause the video, you can see that this splice, and I still have the red. So you can see like a splice would be happening like right here, and then a splice would be happening like right here, okay? So what I'm saying is where you see these red dots, the wire nuts, where we're actually making our splice. So we actually have 3 wires under each of these splices, and then this would be 2 wires under this, where the wire's actually coming into the box, and then from the light where they have their pigtails, those go on to the splice. So when we bring this back up, when we see these red dots, that's essentially what it is, but it just looks confusing when you're looking at something like this, okay? So we are going to cover this in just a moment. We're going to get into parallel circuits. I first want to tackle what we're actually looking at when it comes to a parallel circuit. So in other words, what are the main things that you have to remember in a parallel circuit? In a series circuit, like I said, it was just essentially you just got to remember current is always the same. In parallel, voltage is always the same. Another really powerful thing about parallel is it's multiple paths for current to flow. Okay, so what that means is that if we remove this, for example, like imagine this is live, and then all of a sudden we disconnect the splice, this connection is still working out there in the real field. And that's also a huge benefit of a parallel circuit. Whereas if we had a series circuit where it's like this, and then we come back to our source, okay? If we remove one of these, then the whole circuit is now what's called open. There's no current flowing. In a parallel circuit, right now, current would be flowing here, current would be flowing here. If we remove this one, again, by removing this splice, then this circuit is still working, okay? Very, very powerful trait of a parallel circuit. And also, like I said, if 120 volts is right here, 120 volts is coming right here, we're making our splice. There's no resistor. There's nothing changing the voltage up to this point. So when we splice on, 120 volts continues on. And so we have 120 volts going down, 120 volts going down. And that's what makes parallel so powerful is that, again, if this is the light bulb, it is getting the same brightness. It's getting the same voltage, okay? So let's go back a little bit and let's just cover a couple more characteristics of parallel. So voltage is always the same. There's multiple paths for current to flow, right? So current can flow down here, current can flow down here. Now what happens is, let's say 3 amps is going down here, and let's say 2 amps is going down here. So what would happen is actually 5 amps, okay? So we have 5 amps coming this way, 3 amps is now going down. So we now have 3 amps. What happens is actually 2 amps is going this way and 2 amps is now going down. So 2 amps is still continuing over here. And then what happens is right here, they get added up back to 5 amps, okay? So that's something to know about a parallel circuit is that all of your branches current gets added up. Okay, whereas in a series circuit, current just stayed the same. And so essentially this part of the wiring right here, so not including the resistor, so just this part, this is what's called the home run. And this is why it has the 5 amps, because that is the home run from the panel. So this right here would be from the panel. Let's say it's circuit 1 or circuit 2. It has a black and a white, right? Let's say it's a number 14, so 14-2. The home run carries all of the current, but when you splice on, then that branch is only carrying, let's say 3 amps to this light bulb, and then let's say only 2 amps to this light bulb. Okay, so the very, very last one that is very, very important to know about a parallel circuit is that resistance, total resistance, is always less than any of the branches, okay? So I'm just gonna write that. All right, so total resistance is less than any branch. So when we have our T's, okay, and so if we have R1, let's say right there, and then we have R2, so what's happening is, let's say we have 10 ohms here, and then we have 7 ohms here. So what this is saying, a thing that you have to know about a parallel circuit, is that the total resistance is always less. So for example, you know, it could be 6 ohms, it could be 5 ohms. It cannot be more than 7 ohms. It could be 6.999 ohms, but it cannot be more than 7. All right. So when you are out there doing your test, remember, in a parallel circuit, voltage is always the same. And the next most important one is that total resistance is always less than any branch circuit, okay? So this is called a branch circuit. This is a branch circuit, okay? So if it's 7 ohms, then it has to be less than 7 ohms. If this was 4 ohms, then it has to be less than 4 ohms. It could be 3 ohms, it could be 2 ohms, or again, it could be like 3.999 ohms or whatever. It always has to be less than any branch. If you can remember that, you're going to do really, really good on your tests, because if this one right here has 10 ohms and then all of a sudden you say, oh, well, I have 15 ohms here, that's a clear sign that that can't be. You have to have your resistance here has to be like 9 ohms or has to be less than 10. Okay, so let's just add one more on here, because we'll just do one nice big example, okay? And again, I'm just going to do this just for you guys to see that this is where we would actually be making our real splices in the real world inside the octagon box. Okay, so this one here is R1, this one is going to be R2, and then this one here is R3. Okay, so I'm just going to write in some numbers here. Again, always make your T's, always make them just a little bit bigger than what you think. So now I'm going to enter in some values here, and then we will actually figure out the equation. But again, to keep things simple, let's just draw Ohm's law up here. So V, I, R. And then we also have the power triangle, so P, I, V, okay? And so if we were wanting to find the value of voltage, then it would be current times resistance. So current times resistance gives us voltage. And if we want to find the value of resistance, then it would be voltage divided by current gives us R. All right, so it's a little triangle, and that's exactly what this is, V, I, R for all of them, okay? Let's just say we have 120 volts, just like out there in the real world. So if you follow what was going on, there's no like resistor in line. So in other words, there's no voltage drop. So what's going to be happening is this is the same, what's called potential. So in other words, we have 120 volts going this way, 120 volts is going to be dropping right here, right? 120 volts is going to continue. Again, there's no resistor in line causing a voltage drop. So in other words, all of these places where we have spliced, they all get 120 volts, okay? Whereas again, in a series circuit, if it's like this, and we have 120 volts, then here we're going to have a voltage drop, here we're going to have a voltage drop, so we might have like 60 volts and 60 volts. But what we have in like a parallel circuit is it's essentially just like one resistor from the main voltage. So in other words, our voltage drop here is 120 volts. And so essentially what we're doing is we would be splicing on here. Now we have another resistor, we have another resistor, and we're getting 120 volts across everything. And the reason why we want to do that in the real world is because it allows us to have the same voltage at all of our plugs, all of our lights. We all get this same brightness across our lights, and we're providing the right power, or sorry, the right voltage to all of our equipment. Okay, so let's say R1 has 20 ohms. Let's say R2 is 17 ohms, and then R3 is 10 ohms, okay? So we can just do basic Ohm's law here, but we're not able to add up our resistances like we were able to do when it came to series. So for example, it isn't like 20 plus 17 plus 10 to give us this. Remember, this has to be less than 10. And then from here, we can just simply find our amperage for each of these. They get added up, and it's going to give us our total amperage. Let's just do our math here, and we will just follow through, okay? So we have 120 volts divided by 20 ohms, and that is going to give us 6 amps. 120 volts divided by 17 ohms is going to give us 7.05, and this is going to be 9 amps. So as you can see, 8 pushes 9 up. And then now we are going to go 120 divided by 10, and I'm just going to go 12 amps. Keep it simple, okay? All right, so we have 12 amps coming down here, which means 12 amps is coming over here. And then what happens is coming down here, we have 7 amps. It's actually 7.059 amps, okay? But what happens is these get added up. So right here, it is actually 19.059 amps is going through. And then we have 6 amps coming down. And again, it just gets added up. So 19.059 and then plus 6. So right here, we have 25.059 amps. And this is our home run, okay? This is essentially like the neutral, but we also have it going on the hot as well. Okay, 25.059 amps. And that's what we'd have right here. And again, that's what I was trying to say. Always make your T's bigger than what you think, because it's going to be very hard for me to put this value in. So let me just erase this. I'm going to make the T easier. All right, so we have 120 volts. Again, always make your T's bigger than what you think. And then we have 25.059 amps, okay? Now, what we can do here is we can just figure out our total resistance like this. This is, by far the easiest way is adding up your amperages to get your total resistance. But when it comes to a parallel circuit, there's actually many ways to find the total resistance in a circuit, and I'll cover a couple of those in this video. But usually I have found this is the easiest way to figure out your equation is, first of all, find your voltage, which is going to be the same usually. And then you can get your amperage, and then you add up your amperage, and then we're just going to do a simple division. And again, you are going to see that it's less than 10. Okay, so let's just go 120 divided by 25.059. And so you can see our total resistance is 4.789 ohms. And so that is essentially how a parallel circuit works. So there's actually like 4 or 5 different ways to find total resistance in a parallel circuit. But like I said, finding your amperages, adding them up, that's probably like the easiest way. But let me show you another way here, okay? So again, let's just draw our T's here. So I had 20 ohms, we had 17 ohms, and then we had 10 ohms, okay? And so again, this is R1, R2, and R3. And here is our total resistance, okay? So again, if we had 120 volts, then we can just figure it out just like how we did. But here is just another trick for how to figure out total resistance in the circuit, okay? So this one's a little bit tricky, and you have to use the scientific calculator for this. Now, you can do like the common denominator one. There is also like the product and sum one. I've always found those very, very confusing. There's one way which is also pretty easy once you understand the formula, okay? So this is how you have to do it. Watch really, really close how I put in the math formula into this calculator. So first of all, you're going to go 1 divided by, and you go bracket, bracket, okay? And so all you're going to do now is you're going to go 1 divided by 20. You close the bracket. You're going to hit plus, and then it's going to be you open up the other bracket, and you're going to go 1 divided by 17, close the bracket, plus, open the bracket, and then 1 divided by 10, okay? And then you can close the bracket. And so when I hit enter here, you're going to see that I get 4.789 ohms. Watch this. If I hide this layer, bring our other layer back, what we did with all our currents, it is the same value, okay? So that is another way to figure out total resistance in the circuit. And another thing to say about a parallel circuit is the more branches we have, so in other words, as current increases, resistance decreases, as you can see right here. So let's just quickly recap on what we've done. So voltage is always the same in a parallel circuit. A parallel circuit allows multiple paths for current to flow. As you can see, here's one branch, that's one path, that's 2 paths. In a series circuit, there is only one path for current to flow. If this burns out, the whole circuit stops working. But if we're in a parallel circuit and we remove this branch, these 2 branches will still work. Here's just a couple of those equations of what we wrote in the series. So voltage total is equal to voltage 1 is equal to voltage 2 equal to voltage 3. And so what that's saying is voltage total, so 120 volts right here, is the same across all of our branches. And that is because we are splicing with no resistor, nothing changing the potential. Now, I total is actually equal to I1 plus I2. So in other words, we can add these up, right? And then I3. Also in a parallel circuit, we actually can add up our power, so our wattage, and running out of room here. So I'm just going to draw over here for the resistance. Now here is what that looks like. Okay, so R total equals, and then, so this is what it is. So 1 divided by, and you go 2 brackets, and it would be like 1 over R1. Okay, but let's just go 120. Okay, so whatever your value is there. And then you're going to plus, and let's just say we have 2 because I'm going to run out of room. And then let's go 1 over 17 ohms. Okay. And then we just close the bracket. Now again, once this is into your calculator, you have to hit equals, and then you will be presented with your total resistance of the circuit. Okay, so that is parallel circuits. If you guys would like to check out the series circuit, I will leave that link in the description. Be on the lookout for the next video, which will be combination circuits, all right? I'm trying to explain this in a way that relates to us as electricians, because a lot of the stuff that we're really looking at here is like electrical engineering, and electricians are not engineers. Like, we just need to know how to look at the prints, what wire size to run, what voltage that equipment requires, how many phases it requires. But this is just going to allow you to understand the difference between series and parallel. If you have any questions, make sure to leave comments below. Be on the lookout for the upcoming video, which will be combination circuits, where we will be starting to have series and parallel. And again, this is also a purely resistive situation. We're not dealing with inductance and capacitance, like I said before, where we are dealing with Pythagoras theorem, where you're trying to find out the longest side of your triangle and trying to find out efficiency, which is called power factor, okay? All right, I will talk to you in the next video. If you guys would like to stay updated with the website, you guys can sign up for my free book by going to becominganelectrician.com/subscribe. I wrote it specifically for electrical apprentices. You guys will learn a lot, and you'll stay updated with the website. I'll talk to you in the next video.